This device measures the speed of an object that passes through these two lasers. And using just these two laser tripwires, we can also measure the height from which the object was dropped and the width of the object as well. So here's a carrot. We can show the same thing. It says, okay, 14 centimeter drop height, object width 2 centimeters, compared to the apple, which was 6.5 centimeters. So you can see it's somewhat accurate, and which is amazing, especially considering that this is made out of a piece of trash with some pencils stabbed into it as to hold the tripwire. So I'm going to show you how this thing works. Okay, first let's look at the circuitry of the device. On the left here we just have the two lasers powered by 5 volts. They're constantly shining their light onto a couple of LDRs over here. My Raspberry Pi is constantly monitoring the output of the LDR, and with this voltage divider it will read high when the laser is shining on the LDR and low when something has passed between the laser and LDR. And in the back end we have some code that's monitoring these GPIO pins, so let's take a look at that next. Okay, so here's the script that's running the device. What we have is just pretty much all comes down to this while loop that's just constantly checking to see if our GPIO pins have the same value as the previous reading. So as soon as they change, this inner block will be triggered, which just records some times and sets the status, the updated status of the pins. And then as soon as a specific condition is met, which is right here, if basically I'm just checking to see if the object has passed through both of the lasers. If it's done it in a specified amount of time, then we basically just print the width and the height, or sorry, this is just printing the stats of the object it's falling through. That functions up here. We have this right here. It's pretty simple. It's just applying some basic formulas from physics, which I'll show you in a bit. But yeah, you could you're basically taking in the time it took for the object to go from one laser to the next, and then the time it took for the laser, or for the object to pass through a single laser. Just with those two pieces of information, we calculate the rest of the stats. So I'll show you the physics that gives us our velocity equation and our height and width. Okay, let's take a look at the math. Here are our equations that we're using from physics. This is what you learn in most introductory physics courses. These are the kinematic equations that describe the motion of point-like bodies when we're only considering constant acceleration. So to get the first stat is the velocity at the top laser. We can get that by just rearranging this equation here, and assuming that the acceleration is just the force of gravity, ignoring air resistance and yeah, using our measurement between these two lasers, which is not very accurate, but that's okay. And then from there, we use this velocity to get the width of the object by just multiplying it by the time it took for the object to pass through this laser. It's not perfect, but it works well enough. And then we can get the drop height with this equation right here. Since the initial velocity is 0, we just divide by this stuff and we get this equation right here. And that's how it works. Alright, so that's the project. There are a lot of problems with it right now. The main one being that the support structure sucks. It's made out of a piece of cardboard with pencils stabbed into it. It's by no means a scientific instrument. Its purpose was just to as a proof of concept of an idea I had, and it worked at that. But if you want to make a project like this yourself, as you're going to want to make a few improvements, mainly measure out the distances between the lasers and the LDRs. Make sure everything is perfectly square, as perfect as you can get it. Make a precise measurement between the lasers, so you can, because that's what's used to calculate all these statistics. And yeah, make sure everything is bolted into place instead of just being taped into place like an iron is. And yeah, I think you should have a much better time than I did and have a better instrument. So yeah, that's it for this video. I'm planning on uploading more videos like this in the future of electronics and programming projects. If that's something you want to see, please leave a like and subscribe. And thanks for watching. Goodbye.